Welcome! In this video, I'll talk about how to find average atomic mass given information about isotopes. Included are also a variation of problems in order to find isotope masses or isotope percentages. The goal of this video is to make you feel more comfortable finding average atomic mass and other related variables. Now, what do we mean by the averages, by the isotopes, and the masses? First, an isotope is going to be an element with the same number of protons, but a different number of neutrons. And then mass is pretty much self-explanatory. It's like mass of any other thing, so kind of how heavy it is. The idea here is that you have one element, but it has multiple isotopes. So there are multiple varieties of it, each with a different number of neutrons. And percent abundance is going to try to describe how much does one isotope contribute to the average. So you have an average atomic mass, but some isotopes occur more abundantly, some occur less abundantly, and some are heavier than others. And so you'll have that percentage. One of the numbers you'll see when you look at a periodic table is the average atomic mass of that element. So those are the known elements, and for those, the isotopes that have been discovered have been averaged out. And so on that table, you'll see, for example, 16 for oxygen. And so 16 will be the average atomic mass for oxygen. Here is the equation to find average atomic mass. Here, you're going to take the percent abundance of isotope 1 and multiply it by its mass. Then, if you have another isotope of that element, you will take that percentage of the second isotope and you will multiply it by the mass of the second isotope. You will keep doing this each time. So if you have a third one, then down here, you would have the percentage of isotope 3 times the mass of isotope 3. And you would go on and on and on until you finish with your isotopes. Here we have our first example, and we want to find average atomic mass. And so I'm just going to use the equation from above. I'm going to focus on one isotope at a time. So here I have my first isotope, all right? And so I should multiply the percentage times the mass of that isotope. So we can even call this isotope 1. Now, it's important when you're given the percentage that you convert the percentage to a decimal. So you can do this by either moving the decimal 2 places to the left, or that's the same thing as dividing the percent number by 100. For isotope 1, we're going to have this percentage, and I'll divide by 100 to get it to decimal. And then this is going to be multiplied by the mass of isotope 1, which we are given as 55.3 AMU. And then we're going to add this to the information of the second isotope. Now, the second isotope says the remaining percentage is taken up by the other isotope with this mass. So you should assume in these isotope problems that the percentages add up to 100. Therefore, the other missing percentage is simply 100 minus the percent we already know, which is 41.89. So isotope 2 has percent of 58.11. Remember, we have to convert to decimal, so I will divide by 100. Then we will multiply this information by the mass of isotope number 2, which is 51.99 AMU. If you do this math, you're going to get 53.38 AMU as the average atomic mass. Now, knowing what you do from the last problem, try to find this element's average atomic mass. This element has 4 isotopes, and we're given information for each. So I'll focus on one isotope at a time. Isotope 1, I'll write in white, and so I'll do the percentage converted to decimal, multiplied by this mass of isotope 1, which is 122.57 AMU, and then we'll have a second isotope, I'll write in blue, so we have this percentage and this mass, and so I will add this to, let's convert this percentage to a decimal by dividing by 100, and we'll multiply by this mass. So I still have 2 more isotopes to go, so I'm going to keep adding. The third isotope says we have a mass of 120.5 and 20%. So third isotope should be 20 divided by 100 to convert percentage to decimal, times the mass, and then we finally have our last isotope, and so this last isotope has this mass and this percent. Okay, so on to our fourth isotope, we have a 10.8%, convert to decimal by dividing by 100, and then we have this mass. Okay, and that is all of our isotopes, and so now you can put these numbers into your calculator. When you do this mass, you're going to get an average atomic mass of 111.89 AMU, atomic mass units. Now here is a different variety of the same ideas. So an element has 3 isotopes, and we are given the average atomic mass. And our job is to find the missing information where these question marks are. So we need to find the mass of isotope A and the percentage of isotope A. Now remember I said that the percentages here should add up to 100? Well, we can just find the percentages just like that. So we have 100% minus the known percentages, minus 15, minus 45, and this should give us the percentage of isotope A. So already we can fill in that isotope A is 40%. Now, how do you think we're going to find the mass of isotope A? It turns out if you do some algebra, you're going to use the same equation that I showed above, but we're just going to switch a few things around. So remember, the average atomic mass, I'm just going to put AAM, is going to be equal to the percent abundance times the mass of that isotope, and we're just going to keep doing that until we finish all the isotopes. So in this case, it would be 3 times. Now, if we said that this information is specifically for the first isotope, isotope A, then our question would be, what is this mass? Given that we know this and this information, and we also know the average atomic mass as 17.45 AMU. In order to solve for mass, that's basically saying I want to have mass of isotope A on one side and all my other things on the other side. Basically, we're just going to plug in values. So this is for B and this is for C. And so we just plug in the values. So here you're going to put the 15% divided by 100. And then you're going to have the mass of isotope B, which says it's going to be 16 AMU. And then over here you have C. So you're just going to fill in the information. C has percentage of 45% and its mass is going to be 19 AMU. Another piece of information is, of course, the average atomic mass, which is 17.45. Now we also know the percentage of isotope A because we just found it as 40%, so you'll want to convert that to decimal. Okay, and then once you do that, you just switch this around to solve for mass. So you would want to subtract the information of B and C so that they land on the left side, and then you would want to divide by this percentage so that it cancels out on the right side and goes to the left side, leaving mass alone. Now to show you how this would work, I have calculated the information for B, which is right here, and the information for C, which totals this AMU. And I've also put this percentage of A into decimal form. Now to solve for the mass of A, let's subtract these two parts on both sides. To solve for the mass of A, let's subtract this green part so that it appears on the left side. That's going to be 17.45 minus 2.4 minus 8.55. That's going to be equal to 0.4 times the mass of A. Subtracting 2.4 and 8.55 from the right cancels these out. On the left, you'll get 6.5 AMU, and that's going to be equal to 0.4 times the mass of A. Finally, you're going to divide both sides by 0.4. 0.4 will cancel out on the right, and on the left, you'll have 16.25, and that will be equal to the mass of A. All right, so isotope A has 16.25 AMU. Now here's a problem that I will leave for you to solve and answer in the comments. Now that's it for this video. I hope you enjoyed it. There's a link down below for science and math tutoring, my publications, and my website with other free resources. Thank you so much for watching, and I will see you next time.